Good morning, good morning, good morning. My name is Jeffrey Palermo, and I'm the Chief Architect of ClearMeasure, and we're a DevOps-Centered Software Engineering company serving the greater United States, and we even have some international customers. But over my 2 decades plus of working with custom software, I've seen scores of modernization projects, and I know the challenge that an aging system poses to you guys. And so today I'm going to show you a faster path to software modernization, regardless of which of the three major strategies that you choose. And I know how busy you are, and my goal is to not take up a full hour for this webinar, but to get the information delivered and in and out. Some logistics. Um, we have a really, really great crowd on this webinar. If someone could help me out and just in the chat, let me know if the audio is coming through loud and clear, and I'd appreciate that. Also, there's a Q&A window. If you have questions during the webinar, you can place them there. And if I don't work them into the webinar, if I don't work them into the middle, I'll make sure that all of those questions are answered before we drop off. So awesome. Thank you very much. Thank you very much for that response on the audio. And we have a good mix of crowd on this webinar. It's a very popular, tremendous response, but we have some lead architects, some CIOs, some development managers, some development leads, and it looks like all of you are running a software team or are responsible in some type of leadership for a software team. And invariably, if you're coming to this webinar, you have an existing aging legacy system or a system that you would like to modernize, update in some way. And it's been a challenge. So I hope that this information can be helpful in that regard. So for today's webinar, by the way, you can chat amongst yourselves using the chat windows, and we're going to talk about the challenge of aging software and why we find ourselves in need of a modernization. Then we'll explore some symptoms of an aging system. We'll look at the overall roadmap of how to plan your modernization, including available strategies, the details of each strategy, and then the value that you'll acquire when executing that strategy. At the end, we'll share some ways that we can be of assistance to you in your modernization initiative. Okay, so the challenge. You might call it a legacy system or not, or have some other name, but a system that's showing its age is not going to be resilient to change any longer. And when it goes down or has stability issues, business disruptions occur. And these systems are important. These systems are no longer able to change at the pace or in the way that is necessary for your organization to execute its go forward strategy. And when the software system starts holding the business back, you have to address it. So let's dive into the problem a little bit. We have an aging system, a legacy system. It could be an old platform. Certainly COBOL mainframe systems are called legacy systems, but there are many clients actively doing, new fresh development on COBOL. But I mentioned that to illustrate that an older platform can be a symptom of a legacy system, but not always, because a lot of our clients also have a lot of significant Visual Basic, Delphi, active server pages, platforms that kind of at the end of the 90s were end of life. But if the system has become inflexible and you can't do what you need with it, well, now that's the biggest problem. So this system, it may be mentioned in development meetings. Your developers may be calling for replacement of the system, maybe even the users. The managers may be reporting problems retaining your developers or recruiting new ones. For instance, a software engineer candidate may be opting for other companies when they learn about the software system that they would be working with. And finally, you might be experiencing instability. If changing something in the system, break something in a seemingly unrelated part of the system, then your staff is going to become fearful and hesitant to make changes. And so these are symptoms that we all see, but there could be root causes lying under the surface. And so some of the common root causes you see on the bottom right are lack of proper maintenance, just like any significant thing that is built, whether it be a high-rise skyscraper or a fleet of trucks. If you don't do proper maintenance, then things are going to fall out of disrepair. The perceived lack of opportunity by developers, and then an insufficient development environment, which we find that is plagues a lot of these. But let's dig in a little bit more. Okay, so let's talk about strategies and what roadmap you would go down. There are 3 strategies for modernizing an application. There's really 3. I mean, you could, within each of these 3, there's any number of ways that you can execute in details, but there are 3. And so the 3 strategies for modernizing an application are: 1, package replacement, 2, rewrite, or 3, fix and upgrade. Regardless of the shades of gray, these are the 3 strategies. We'll ignore what might be a 4th strategy, which might be the strategy that you're on now, which is to do nothing and wait out the problem, which is not really a strategy. It's just a lack of action. But each of these has some benefits and it has some drawbacks. And one, you might have already chosen a strategy. You might already be down the path, but let's go through them one by one. The package strategy promises to be the quickest to a full replacement, but it's still not quick or cheap. We're talking about 7-figure budgets for any of these, because if you already have a custom software system, the reason you probably haven't modernized already is because you look at the price tag of maybe one of these strategies and it's too big, so you just delay. But the package sellers, they tout faster timelines than a full custom rewrite. And, in a lot of cases, they would be true. If you could find a package that would satisfy all of your needs, then putting it in place would likely be a faster timeline than a full custom rewrite. Of course, if you can't find a package and you know that the system absolutely needs to be custom because there's no package out there, okay, well, you can eliminate this strategy. All right, second strategy, you could rewrite in a modern technology like C# or Azure. Or the third one is you could fix the problems you are having with the system. And invariably, there's problems that people are calling out and they haven't been fixed for a long time. So as you look at the time frames, the marker of value is called out for the first time that your users could actually see value from the initiative. For the package replacement, you're going to need to do a lot of work, then get some of the people onto the package, and then you can kind of iterate on the package configuration once people are actually using it. With the full rewrite, you have a longer time frame until the people start actually using it and then iterating. For the fix and upgrade strategy, people are already using the system. So if you can fix something that's wrong with the system or holding back a business initiative, then your customers, your users could see the value very quickly. Now, I want to call something out. The third strategy here, it kind of seems far-fetched, doesn't it? You're looking at the first two strategies because your people have tried and tried to fix and upgrade things for years, and you still find yourself with a system resistant to change. So strategy 1 and 2 look promising, and of course, if you can't find a package that fits, then strategy 2 looks promising. Oh, but it's so expensive and it's got such a big project. But because the duration you'd have to wait until real usage is a problem. So if you can't change your system, if you're in that situation now, you have to replace it. But then you have a risky cutover event down the road, 18 months to several years. That's problematic because your business can't do nothing for 18 months. These are big, significant systems. All right, so let's figure out how to get some value quicker. If we can segment the system and do some interim releases, then we can capture the value quicker, regardless of the three strategies. If we have to implement a package or do a rewrite, and we can't have people using it until it's substantially finished at the end, then that's a long time. But if we can segment that implementation, have some people start using it earlier, then we can capture value quicker. Okay, so that's a better way to execute the same strategy, regardless of which one you pick. But if we are going to have a release where some of the new and some of the old are in place, then we have to be able to change and refactor our existing system, because we'll have some people using a new system, whether a package or rewrite, some people using a new system for some capabilities, but then user will be using the old system for the other capabilities, and they'll have to be integrated together. So we realize, and it is a reality, that regardless of the modernization strategy that we choose, we must regain control of the system that we have. Many people look for a replacement, whether a rewrite or replacing with a package, because the existing system, we lost control of it. And that's really the root cause. We have lost control of our existing system. So we have to regain control of that. Otherwise, if we don't, we are going to commission a long and expensive project and be set up for a high risk big bang cutover event. And we all know how those types of projects love to fail. I'm not here to sell you on a strategy. You've got 3 strategies you can pick. The 4th non-strategy is to do nothing and just kind of wait and do. But I'm not here to tell you which one to pick, because all of these are viable, and there's companies all over the place doing all 3. But I'm here to tell you that even though you have an aging legacy system that's hard to change, you have to do what is necessary to regain control over it. If you don't, you're sunk. When you do, you can choose any of these strategies that may be appropriate and be in control of the modernization and be set up to succeed. So let's talk about how to regain control. It's more than just having a way to execute changes. This change cycle you see on the screen probably looks familiar to you, and it revolves around a way to build and deploy the software. But it's woefully incomplete. So you've heard of DevOps, and of course your legacy system is not set up with any kind of DevOps automation, whether it be build or deployment or automated test suites or environment recreation. But that is the first step to regaining control of your existing system. Even if you're going to replace with a package, you're going to have to do some kind of integration. You're going to have to support that existing package for the next extended period of time, and you're going to have to segment and integrate it. And so you have to regain control. All right, to execute our modernization and gain control over the system, we have a model for this. And regardless if your system is an older platform that's out of support, or if it's just an older .NET version, or even if you have a poorly designed system that you inherited, you need to be able to change it in some ways to make some architectural seams or cuts. The center of this model is the foundational infrastructure necessary to make changes and redeploy them. But there are other layers of capability that are needed as well, and you'll use these to regain control of that system during the entire modernization as you make some fairly significant architectural transitions. So of each of these layers, each must have a sound strategy, be executed with discipline, and have objective measures, and we'll go through those. I want to pause a little bit before we move on to the other layers. I want to show you the basic structure of any automated DevOps pipeline. And by the way, I understand that this is small, but bear with me for a second. You absolutely have to have an automated pipeline for every application you manage, aging or not. And not having one almost guarantees that it will show its age as soon as the original developers leave the company, and maybe before. And this right here, what you're seeing on the screen, is part of a larger design poster. And If you post in the chat or follow up afterwards, I'd be happy to send this DevOps poster to you as a full-size PDF. It's formatted for architecture D paper, so you can print it on a plotter and hang it up if you like, or send it to a print shop and do a full 2-foot by 3-foot printout. This is only the top third of it for the basic structure of a pipeline. And you notice that there's 3 environments. You'll never have fewer than 3 environments because each one has a different purpose. You might have many more, but you'll never have fewer than 3. And you can check out our other webinars to find out why. But this is a highly shrunken technical blueprint for the structure and the flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy with continuous integration build, 3-tier deployment pipeline. So no matter if your system is really old or just an aging design, your environment starts with this, and you'll continue to have a very hard time making any changes without this basic infrastructure. All right, so let's dive into these layers one by one. And I'm not going to read all the text on the screen, but in the top right, if you haven't considered this, your beginning state may have some elements of that there on the screen. We're looking for the ideal state, and some of the options are going to be on the left. So there's many practices available to you, but there are some of particular usefulness in a modernization. By the way, there's so many best practices out there that no single project could ever make use of all the practices that are labeled best practice. You're going to have to choose. There's just too many. So feature branching, that's one practice. It's making small changes and redeploying frequently and having short-lived branches. And another practice is refactoring, improving the structure of existing code without changing its behavior. That's how we make architectural shifts without changing behavior. And then continuous integration, which brings together changes of various people so that no single change is large and the main line of the code always stays clear, always stays stable. All right, the next layer, defect removal. So big changes happen during a modernization, and you need to be able to find the defects that are caused by the changes. So start with full system testing, which is the inverse of test-driven development. For testing, we normally start with small unit tests, then go to component level integration tests, then go to full system tests. If your system has no tests, if it's been around for a long time and absolutely is all manual validation, start with automated full system testing, then work backwards. It's the opposite when you're coming with to a large system with no tests. Next, do formal recorded regression tests with Azure test plans so that you can see, so that we know and have documented the transactions that the system needs to support. And then another practice is to create a definition of done for each change, for each refactoring. So if we need to segment a certain module or a certain segment of screens because we're going to cut over to a new system or a package or just make a split, we're going to refactor the architecture and split things apart, we need a definition of done. We need covering tests that test those change capabilities and other checks to keep you safe, and a diagram of where we're going to end up. All right, so the next layer is team workflow. We need to get back in control of our system. And so for your Kanban board or the swim lanes on your project board, add extra columns to that board. For example, you might have another column called understand user scenarios and quote, create covering tests. If you've had staff turnover, your people likely won't be expert power users in how the system is used in various scenarios. So when changing something, special time needs to be allocated for filling in these knowledge gaps, for talking with users. Record the users demonstrating how to use the system for common tasks they perform daily so that you really understand that and can create those full system covering tests and spend time doing that. All right, the next layer is architectural blueprints. So in 1995, Philippe Christian created a model called the 4+1 view model of software architecture. And it's a model for iterative emergent architecture. If you have it, great. Update that 4+1 architecture. If you don't have it, create it. Get around a whiteboard and try to do some archaeological digging and recreate the architecture of the system, because you're going to need to have a transitional state of the architecture as you insert some seams, as you break it apart, so that you can execute a modernization strategy. So you want to cast that to-be vision. Then you want to, after you have the to-be vision for what it's going to look like at the end, draft transitional architecture states at each milestone and use this to align the team and to inspect what is changing. And then, well, as an aside, a replacement pattern that you could consider is the strangler pattern, whereby you refactor parts of the system to disconnect them or take them offline one at a time as another system takes charge of that. And then you just leave the code there dormant. If that's less turbulent than removing the code, or if removing the code causes the structure to start to crumble. So strategically, you're defining what is being built or changed, what is cleared for investment, and what's deferred. Every professional that builds something or changes something uses design drawings and design models in the communication of what's to be built. And teams that lack this are constantly struggling to place the same image in the minds of each team member. In our consulting practice, when we're helping our clients, we often ask how the system is structured. And far too many times we spend over an hour in a conference room harvesting the architecture out of the heads of the team members and then drawing it on the whiteboard. So architectural blueprints are a way, it's the definition of what's to be built. And it's a tool for team alignment. You can imagine a business with no business plan, market strategy, or quarterly goal. You can't have alignment there. Next layer is cloud operations. You want to assess the state of your logs and your observability in that legacy system. Add more telemetry, provision a centralized log and analysis environment. Then recreate a new production-like environment. You need to prove to yourself that you can recreate that production environment. If you can't, you're one step away from an outage turning into a disaster. And besides, it'll force the learning required to automate environment recreating and then more invasive full system testing. Again, our goal here is to regain control over our systems so that we can make the needed changes as we move along with any of the three chosen modernization strategies. Okay, so the perceived easy way out of our legacy system, that's hard to change, is just to avoid it, or to say, hey, I'm just going to replace it and then I won't have to deal with it. And then, yeah, it'll take a long time, but just reinvest all that money. And you're going to build something up next to it, then cut over. Man, it's so risky. But facing the storm gets you through it quicker. Let me give you an analogy. Out on the Western Plains, there's buffalo and there's cows. And from the Rocky Mountains, storms normally head from the west to the east, in the middle of the country. So cows, when they see the storm coming, they'll start walking east because they just want to get away from the storm. And the herds of buffalo, when they see the storm coming, they start heading west, straight into the storm. What happens is the cows, they're marching east, and then they eventually get to a barbed wire fence, kind of at the end of these large extended ranges or ranches, and then they can't walk anymore, and the storm comes and it overtakes them, and they just kind of get wet. The buffalo, they're heading into the storm, and so they get to the storm first, but because they're moving to the west and the storm is moving to the east, they actually get out of the storm faster, and the herd of cattle end up in the storm longer. So be the buffalo. You see the storm. There's no way to avoid it. You can delay for a little bit, but head into that storm and take the action necessary. So we have plenty of examples of customers that we've helped regain control over their software and be better at maintaining it and developing it and growing and changing it. There's more available on our website. We'd be glad for you to be one of them. And one of the easy ways to get some help is to it could be really small. Have us do some architectural advisement or consulting just to formulate a plan or do an assessment. If you'd like a second pair of eyes on your organization, environment, process, or that legacy system, we're happy to help here. Our goal is for you to be completely self-sufficient and for your team and for your software organization to be absolutely world-class. We believe that every software engineering organization can be world-class and compete with all of the technology companies that you hear in the news, and happy to do that. So um, looking at the Q&A window, we see quite a few had interest in the poster. That's awesome. We will be happy to send that over. Let's see, here is contact information. And yes, this is my direct phone number. Be happy to talk individually. Here's one of the questions. As we implement the model, do we have to do it all, or can we do just a few of the layers? And that's a really good question. So everything is iterative. Absolutely everything is iterative. If you have the legacy system that is all the people have left and you're just keeping it up and running, everything's manual, nothing is automated, start from the center and iterate towards the outside. So your automated DevOps pipeline, just start with an automated compile and redeploying on existing infrastructure, just replacing files. Just what is the smallest minimum viable pipeline you can get in place? Then practices. Harvest the practices that you're already using just so that you can get everybody on the same page. Hey, these are the practices we're using. Then go to defect removal and catalog what your current techniques are, what your defect removal methods are, and then what the team workflow is. Get the architecture of the system written down, then go to operations and catalog how you are doing operations. And then that, guess what? Now that's your strategy. Make sure you're executing it. But then as the leader, come back to the center and do an incremental improvement on each one. And every one of your development cycles, do a pass at this and make your strategy more robust, starting from the inside back to the automated DevOps pipeline, adding an additional capability, and then iterate again to the outside, making the strategy more robust, and then making sure that the team is actually executing that strategy and measuring appropriately. Okay. All right. So that was a great question. Let me look to see if we have any other questions. Let's see. There was a question about what tools have been useful for modernizing legacy systems. Now, our world, and most of you on this webinar are Microsoft platform. So Azure Pipe, you have three probably choices for your build server. I mean, I know there's more, but the most popular tend to be Azure Pipelines, was called TFS, and Visual Studio Team Services. Team City has quite a bit out there. Jenkins has quite a bit out there for build server capabilities. And for automated deployments, Octopus Deploy has been around the longest. It's the most sophisticated, especially for all the different ways that older systems need to be deployed. The Release Hub in Azure Pipelines has come a long way, and it's viable. And then beyond those two, you have to run a lot of PowerShell script. So for a legacy system, Octopus Deploy is going to have the most support for deploying all the different pieces that you're going to need to for deploying on Windows servers. But that's a good point, good questions. And anything that can run on a Windows server, now there's going to be some outliers, but anything that can be run on a Windows server could be lift and shifted into Windows Server running in Azure, and then give you some more flexibility. That's on the table. A lot of people are doing it. Now, there's some things where you're tied to the data center and you can't get away from it, or specialized hardware. There are those cases. but that's a good question. All right. Um, and it looks like we have a suggestion for another webinar, which I love getting suggestions for new webinars, which would be an end-to-end architectural demo of a complete tool chain that's put together. And actually, that was a request from one person. If anybody on here thinks that webinar idea would be a good one for us to put together, just let us know in the chat, or send us an email, and that would be great. We love seeing webinar ideas. So looks like those are the questions, and lots of interest in that poster. We will definitely uh, see how that people giving second and third motions to the end-to-end working tool set demo. All right, awesome. And it looks like we're good there. So I love doing these webinars. I love sharing. I hope that you guys learned some things. And my email address, Twitter, and phone numbers on the screen. And we will be recording this webinar. If you have colleagues who would like to see it, let us know. Send us an email. Reply to that email that you received as a reminder for the webinar, and we'd be happy to get that recording to your colleagues. Thank you for your time today, and have a great morning.